Hello there, algebra students. Mr. Lawrence here, and I'm making a video for you. Yes, because I know you really care, and I know how hard you've been working. I want to see it pay off for you. Okay, so first of all, we've spent so much time recently on solving absolute value inequalities that sometimes kids get mixed up. They forget about just regular inequalities. So make sure you're able to solve a regular inequality. Why don't you go ahead and pause the video, give this one a try, and then you can watch my solution. Okay, here comes my solution. If you haven't tried it on your own, please pause the video, give it a shot, and then watch my solution. Now, some of you want to add 2 first here. Well, that's not a dumb idea. You're going to add 2, and then on the right-hand side, you're going to get 2 3/4. If you do that, I strongly suggest you turn this into an improper fraction. And I'm going to go 4 times 2 is 8, plus 3 is 11, so this would be the same as 11/4. Okay, I'm not going to do it that way, but if you do, I think that's a great idea. Okay, so here's what I'm going to do. I'm going to get rid of my fractions. Now, by the way, some of you have been doing this. You've been trying to go like this, okay? And there's a whole bunch of things wrong with this. First of all, if I do something to one side of the equation, I must do the same thing to the other. So therefore, it is not okay to multiply the left-hand side equation by 2 and the right-hand side of the equation, or inequality, excuse me, by 4. That is not okay. If I do it to one side, I have to do it the other. I can't just multiply. I have to multiply by the same amount. Secondly, the other thing wrong with this is you're not multiplying the 2, the negative 2 there. Yeah, that's got to be multiplied also. Tell you what, let me go off on a small tangent here. Those of you who have come in for help recently, I've been showing you this. I really wish more of you would come in for help at least a little bit at a time. Let's say I have x plus 3 equals 7. And I tell you to double both sides. Well, some of you are going to go like this. You're going to go boom, and you're going to go boom. So 7 times 2 is 14. And then you're going to say, well, it's 2x plus 3. No, it's not. This is not correct. You see, you did not double the left-hand side. All you did was multiply x by 2. Look, if I have x plus 3 and I double it, don't I get another x plus 3? Wouldn't x plus 3 doubled be the same as 2x plus 6? Right? It's 2x plus 6. It's not x plus 3, or 2x plus 3. So this is incorrect. Let me get rid of that. That stuff was okay. But that's just kind of my side note. And to double, when there's more than one term, is actually to distribute. Yeah, I have to distribute the 2. So I'm going to multiply by 2 here, getting me 2x, and 2 there, getting me 6. Now I've doubled both sides of the equation. All right, so that's why the 2 in this inequality needs to be multiplied by whatever you're multiplying by. I'm going to choose to multiply by 4 because 4 will take care of both denominators. Yeah, because both denominators go into 4 evenly. But then I'm not going to forget to multiply by 4 here. So when I do this, 2 is going to go into 4 2 times. 2 times 1 times x is 2x. Minus 8 is less than. 4 goes into 4 once. 3 times 1 is 3. And now I have this, and I can go ahead and finish solving. Now, by the way, if you had done it the other way, where you added 2 first, it will still work out the same if you do everything correct. So you don't have to do it my way, but you do have to follow the rules of mathematics. Can't make up your own rules there, sir. All right, so now I have x is less than 5.5. And while it's true you can leave it as 11.5, or excuse me, 11 halves, I don't like to do that when I'm graphing on a number line because the mixed number makes more sense to me. So I'm going to put 5.5 on here. Okay, I'll put 6 over here, and I'll put 5 over here. And then it's going to be an open point because 5.5 does not make this true. It is not a solution. What number does make it true? Well, I think 5 does. Isn't 5 less than 5.5? So I will shade towards the 5. And there we go. Okay, so that's problems done. Now we also, before we did absolute value inequalities, we learned how to solve compound inequalities. Well, remember, many of you know how to solve this, but then you try to make 2 separate graphs. This is one problem. So I'm going to put both solution sets on the same graph. So let's see here. I'm going to do the left-hand side first. I'll add 5, right? And that will get me 2x less than 15. I'll divide by 2, and I'm going to get x is less than 7.5. Half of 15 is 7.5. Or, okay, I'm going to subtract 1 from both sides, and I will get, sorry, I'm not sure what happened there, 3x is greater than 29. Then divide by 3, then x is going to be greater. Oh, silly me, look at that. I can't believe I just did that. Okay, so 29, not 29, 27. Yeah, 27. Check your work as you go. Even Mr. Lawrence makes mistakes. If you don't think you need to check your work, that's a pretty arrogant statement. Because I'm a pretty experienced math teacher, and yet I still make some mistakes from time to time. Some of you say more often than not, oh man, leave me alone, be nice. Okay, so in this case, again, it's not, they are not solutions. The endpoints are not solutions. We have open point, numbers that make this true, numbers that are greater than 9. Well, I'm going to shade towards 10, right? Over here, numbers that are less than 7.5, I'm going to shade towards 0, because 0 is less than 7.5. And there you go. Okay. So now we've got an absolute value inequality, and we're going to do 4 things on this one. And I'm going to expect you to do this on the test, so make sure you know how to do it. You can pause the video and try them all on your own and then watch my solution. But I'm going to do 4 things. I'm going to solve it. I'm going to graph it on a number line. I'm going to give the solution set in interval notation, and then I'm going to give the solution set in set builder notation. So when the absolute value is alone, I can split this into 2 inequalities. So my first one is 5 minus 2x, which is greater than or equal to 5. And this is a great OR, right? Great OR, remember that? So I'm going to put an OR there. And then we will 5 minus 2x is less than or equal to negative 5, right? Okay, so now I subtract 5, and I'm going to get negative 2x, don't drop the negative, yeah, see that negative there, don't drop it, greater than or equal to 0. All right, well now I'm going to divide by negative 2. Now some of you go, wait, you can't do that, it's undefined. No, it is not. The rule is I can't divide by 0. Read this, 0 divided by negative 2. It's okay to divide by negative 2. If you're not sure, you have a panic moment in the test, pull out your calculator and try 0 divided by negative 2. You're going to see you get an answer. In fact, you're going to get 0. By the way, I divided by a negative, so the inequality is going to flip. All right, so now I have x is less than or equal to 0. Now I got to come over here and I'm going to subtract 5 from both sides. Okay, I'm going to get negative 2x less than or equal to negative 10. And again, on the test, use a calculator. Don't get that wrong. Don't write, oh, that's 0, they cancel out. No, they do not cancel out. These cancel out. Divide by negative 2. I'm going to get x. The inequality is going to flip. And negative 10 divided by negative 2 is going to be positive 5. So my solution is x is less than or equal to 0, or x is greater than or equal to 5. So there's my first part. Now I'm going to graph it on a number line. And we know what ORs are going to look like. So I'm going to have a 0. I'm going to have a 5. Okay. I'm going to have closed points because they are solutions, right? And I have to shade greater than 5. Well, that's to the right of 5, right? And then I have to shade to the left of 0 because the negative numbers are less than 0. And there we go. So there's part B. So now I'm going to do my interval notation. I love to do it right below my number line. So I'm going to come down. I'm going to do this side first. I'm going to start with 5. And I know it's closed, so I'm going to use a closed bracket. 5 is a solution. I know it's going forever, so it's going toward infinity. I'll never get there, so I leave it as an open bracket. I'm going to stick an OR in between, And then I'm going to come here and I'm going to work backwards. It's stopping at 0, and 0 is included, so therefore it's a closed bracket. Now, it's going towards negative infinity, right? All the solutions, -1, -2, -3, on and on and on. There's part C right there. Finally, part D, set builder notation. The solution is the set of all real numbers x such that x is less than or equal to 0, or x is greater than or equal to 5. And there you go. There's set builder notation. Why don't you try this one totally on your own? See what you can do. If you're still watching, I'm assuming you've already tried it. If you haven't tried it, please pause the video and try it. Okay, now some of you want to break this absolute value apart, and I appreciate that. We want to do that, but we got to get rid of the 7 and the 2 first. So first thing I'm going to do is I'm going to add 7. I'm going to pretend like the absolute value is a variable, and I'm going to listen to Saddam and use inverse operations to get it alone. Once it's alone, then I'll split it up. I'll interpret it into 2 inequalities. It's going to be less than or equal to 12. All right, now I'm going to divide by 2. Oop, I have a mistake up there, don't I? Yeah, let me sneak. I left the 1 out, didn't I? Okay, and then I'm going to divide by 2 on the right-hand side of the inequality too. All right, so on the left-hand side, I'm left with just the absolute value of 3x minus 1. And the right-hand side is 6. So now I'm going to go ahead and solve that. And I think I'm running out of room here, so hold on one second. I can't pause the video as I'm doing this, unfortunately. But let me group these together, and then I can slide them down, because I'm not quite ready to talk about them yet. Oops, I'm running out of room. Tell you what, sing a song while you wait for me. You know, do 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 do. Okay, that should be good enough. All right, hopefully I didn't hurt your ears too bad. Okay, so where is my mouse? All right, so now it's time to interpret the absolute value. So I'm going to break it into 2 different inequalities, right? I'm going to break it into 3x minus 1 less than 6, and that's a less than, so I'm going to write and in between there. Very important, make sure you do that. 3x minus 1 is greater than -6. Okay, so now I'm going to solve each part, and I lost my mouse again. Where are you, mouse? All right, I'm going to add 1, and I'm going to get 3x is less than 7, and then I'm going to divide by 3, and I'm going to get x is less than 2 1/3. And again, it's not wrong to put 7/3 there. It just doesn't make sense to me when I go to use a number line. I'd rather the reader see 2 1/3. Okay, over here I'm going to add 1, and I'm going to add 1, and so I'm going to get 3x is greater than -5, and divide by 3, divide by 3, and x is going to be greater than -1 2/3. There we go. There's my solution. So now it's time to go to the number line. Okay. Now, one thing I didn't really do, I should be checking these. I should be checking these as I go. And the way I can check them, and I'll backpedal and check here, but I can check the different regions. Okay, by the way, these points are not included, right? Because they are not solutions to the inequality. And I need numbers that are less than 2 1/3 and greater than -1 2/3. I think they're going to be in the middle here, right? Bam. Okay. Now, I'll tell you what, before I go on with the interval notation and set builder notation, I'm going to check them. Like, for example, I think 0 is a solution to the set. If I go back to the original inequality and I plug 0 in for it, I substitute 0 in, I will get a true statement if I did my work correctly. So I'm going to come up here and have 2 and 3 times 0 minus 1, and it's 7. If that is less than 5, then I'm feeling really good about this. So let's see. 3 times 0 is 0. 0 minus 1 is negative 1. Absolute value of negative 1 is 1. So I have 2 times 1 minus 7. 2 times 1 is 2, minus 7 is negative 5, which is less than 5. Hunky-dory. All right. Similarly, if I come over here and test, say, 3, I will get a false statement. Well, let's try it. Let's just do it quick. 3 times 3 is 9. 9 minus 1, 8. Absolute value of 8 is 8. 2 times 8 is 16. 16 minus 7 is not less than 5. No, 16 minus 7 is 9. Didn't work. And if I come over here and do negative 2, it won't work either. 3 times negative 2, negative 6, minus 1, negative 7. Absolute value of negative 7, 7. 2 times 7, 14. 14 minus 7 is 7. 7 is less than 5. It's not. You really should check them all and, maybe go back and check this one. Be pretty easy to check, okay? You'll be getting your true statements on this one for numbers less than 0, like, say, negative 1. Numbers greater than 5, like, 6. And you'll get false statements for 1, 2, 3, 4, 4.5, whatever. You don't have to check them all, but I would check all 3 regions. Okay, so come on down here now and look at problems 6 and 7. Okay, remember the absolute value is all about distance. Distance from 0, distance from a center. And look at this number here. It's a negative. Do you think there's any number I can put in for x that will allow me to get a distance less than negative 8? Let's try it. Let's put 100 in. 100 plus 1, that's 101. Absolute value, that's 101. That's not less than a negative. I know. Let's put negative 100 in. Okay, so I'm going to put negative 100 in. Negative 100 plus 1 would be negative 99, right? The absolute value of negative 99 is 99. That's still not less than negative 8. What if I put negative 1 in? Well, I'd get 0. Absolute value of 0 would be 0. 0 is less than negative. No, that's not true. No matter what number I put into this one, I will not get a true statement. When it's less than a negative or less than 0, there's no solution every single time. No solution every single time. All right, take a look at number 7. This time, the absolute value is greater than a negative number. Watch this. Let's put negative 100 in. 2 times negative 100 is negative 200. Plus 5 would be negative 195, right? Absolute value of negative 195? 195. Is that greater than or equal to negative 2? You bet your boots. All right. Now, what about if I put a really big number in, like a million? Well, 2 million, 2,000,005, absolute value of 2,000,005, that's still going to be greater than a negative number, right? This is going to be any real number. This means that on the number line, on any number on there will make this inequality true. Anyone, pi, negative a Google, 2,365,000.1457612, any number, the square root of 10, any number. But on number 6, that same number line, there's not one number in that entire infinite number line that will allow this inequality to be true. So you might want to memorize that. I mean, I talked about it Friday a little bit, but you might want to memorize. When it's less than a negative or less than 0, it will be any real number. If it's greater than a negative, I just misspoke. I'm so sorry. When it's less than a negative number, then it'll be no solution. Yes, no solution right there. When it's greater than a negative number, it will be any real number. Yeah, any real number. In fact, when it's less than a negative or less than 0, it'll be no solution because distances, the smallest distance you can have is 0. All right, that's it for the video. Sorry if it went a little long, but I wanted to cover everything that you really need to understand. Mr. Lawrence signing out. Have a good night, everybody.